What's up everyone? Welcome back to TerryLab. In this video, I'm going to show you a small Python project I built called ContextPlot, and the goal is simple. I wanted to make a water level plot that actually has context. Normally when you plot water level data, you get a line, maybe a wave envelope, and some time labels. It's useful, but it doesn't instantly tell you what the water is doing relative to something real, like a pier or a platform. So the idea behind this project is to take a standard water level time series, add a wave action band, and then overlay a PNG of a structure directly onto the plot, scaled and positioned in real axis units. That way, the figure becomes a quick visual answer to a question like, how close is the water getting to the deck? Or how much wave action is happening near the structure? This script is a complete working example, and I'll walk through how it works. At the top, I'm importing the main tools. I use NumPy and Pandas for data and time handling, and Matplotlib for plotting. I also import Matplotlib dates, so the x-axis formatting looks clean, and Matplotlib image, so I can load the pier PNG. Then I have a section called user knobs. This is where I control everything without touching the main logic. The first setting is the pier image file name, img.png. That's the overlay that will appear on the plot. Next, I control how much data I want to display. days_to_show is set to 2, so I'm only plotting the last 2 days of the dataset. window_yindy is none, meaning it automatically ends at the last sample, but I can also set it to a specific timestamp if I want. Then I add a reference line. In coastal work, you often want a datum line for comparison, so I define MLLW as a horizontal dash line. In my script, the label is MLLW and the value is -1.4 meters. After that, I add an option called clip to deck. This is important because sometimes the wave band looks too big and visually crosses into areas where it doesn't make sense. So if clipping is enabled, I cap the upper wave envelope at a deck elevation. In this example, the deck elevation is -1.25 meters. That keeps the wave band from going above that level and gives a cleaner plot. Now the overlay placement settings. I position the pier in time using fractions of the plot width. Pier_x0_ controls where the pier starts along the x-axis, and pier_width_frac controls how wide it is. So in this example, the pier starts about halfway across the plot and takes up about 1/3 of the width. For vertical scaling, I set the pier height in meters. That's important because the overlay needs to match the y-axis units. In my script, the pier height is 2.35 meters. Then I added direct control of the vertical position using pier_top. Instead of guessing, I pin the top of the image to a specific y value, here 0.2 meters. That makes it easy to align the pier with the plot. I also added an option to position the image by its center, but by default, I'm using the top alignment. Next, I have scaling knobs for the data. I added tide_scale and wave_scale, so I can reduce the signal amplitude if the plot looks too extreme. That's useful when you're testing or when you want a visually balanced figure. Finally, I handle the pier image background. A lot of PNGs exported from CAD tools come with near white backgrounds that cover the plot. So I added a background removal option. If enabled, the script converts near white pixels into transparency using a threshold value. Now for the data itself. In this script, I generate fake water level data, so the whole project runs anywhere. I create a time series at 5-minute intervals, then build a tide signal using a semi-diurnal component, a diurnal component, and a slower multi-day setup component. I add a bit of random noise to make it realistic. Then I create a wave amplitude that changes over time. From that, I compute hit_flow and hit_height, which represent the lower and upper bounds of the wave action around the mean water level. After generating the full data set, I subset the last 2 days using a helper function. That's what I plot. Now, the plotting function is where the main result happens. First, I compute the pier x range based on the time span. Then I compute the pier y range based on the height and the chosen top position. I also make sure the y-axis limits include both the data and the pier overlay, so nothing gets cut off. Then I draw the pier image with imshow. using the extend argument, so it maps directly into the plot coordinate system. I also set the Z order so the pier stays behind the data. Then I draw the wave action band using fill_between, plot the mean water level line, and add the MLW reference line. If clipping is enabled, the wave band stays below the deck elevation. Finally, I format the plot with clean time ticks, grid lines, and a legend. And I save the output as both a PNG and a PDF. That's the full idea behind ContextPlot. It's a simple concept, but it makes the figure instantly more readable because you're not just looking at numbers, you're looking at the water relative to something real. If you want to check out the full project, it's on my GitHub at akeawaysbernard/ContextPlot. The link is in the description. If you enjoyed this, like the video, subscribe to Terry Lab, and I'll see you in the next one.